This episode associates with our mistake in design of a control valve for flashing service. During our design for such control valve for flashing service, we made two mistakes. At first, I'm gonna familiarize you with these mistakes. Then after these mistakes, we made an improvement. But unfortunately, in the first improvements, we also made the second mistakes. So you're gonna also become familiarized with the second mistakes. And at the end, we made another improvements, and finally we were able to solve and redress our mistake. Let's jump to the problem here. Here we have a control valve, and this control valve is designed for a flashing service. Here we have the diameter, and here the inlet of this control valve is a condensate, HP condensate, with a pressure about 42 bar gauge, and the outlet of this uh, control valve is a mixture of vapor and condensate with outlet pressure of 2 bar gauge. So because of the high pressure drop from 42 to 2 bar gauge, uh, these valves experience some uh, flashings, and the flashing calculated for this control valve is about 25%. If we look at the PID here meticulously, we see that the type of this control valve is globe valve. Based on the literature and experience of some vendors or manufacturers of control valves, when we have a major flashing or in control valves, it is better to select angle type instead of uh, globe valves, globe type. Unfortunately, at that time, we were not aware of such experience, we were not aware of such knowledge, and we made these mistakes. And you might ask this question, what kind of mistake? I don't see any kind of mistake here. Let me show you the mistake here. You see, this is the control valve. Here we have a condensate, high pressure condensate with 42 bar gauge pressure, and here is the cage of the control valve. This uh, high pressure condensate passes through this cage, and then because of the high pressure drop from 42 to 2 bar gauge, some amount of this liquid vaporizes, and therefore we have some amount of flashed water. This flash water behaves as a jet of steam, or say we have steam jets like this ones. These steam jets, as you see here, impacts here directly impacts the body of the control valve. And unfortunately, after 6 months being in operations, we had a big hole under these sections because of just these steam jets. After impacting the body, when the impact of the steam jets and the heat is attenuated, is reduced, this steam jets is going to be carried out, is going to be carried with a stream of water, and it's going to go to the deaerator. So you see, glow valve is not a good type for flashing services because the liquid should changes the directions for many times, and when this happens, we are gonna face such problems. We made an order, but unfortunately at that time the vendor was not able to give us the angle type, so it took time to, in fact, provide us with the angle type. And in order to uh, attenuate the impacts of these ones, We made some adjustments on these sites. I mean, QC engineers made some adjustments here, and then we installed the valve again. But here we made another change, and it was a good change. In fact, you can use such experience for your control valves. And what is this? If you look at this, instead of, you see, in vendor datasheet, it was written a general note. A general note was written, and it says that when we have gas, the gas should enter the valve under plug. But when we have liquid, the liquid should enter above the plug. And because of this, these configurations was selected for the project. But for some special processes, for some special applications, this rule can be overridden and this rule can be selected. When we have liquid in high flash services, it is better for liquid to enter from under the cage. Why? You can see the liquid passes through this cage, and after passing through this cage, the pressure reduces from 42 to 40 to 2 bar gauge. But here, based on the physics rules, the impact the flashed vapor, flashed water, which produces the steam jets here, the impact of these steam jets are is not as high as this one. You see, it's gonna select these directions. Of course, I know that in finally one day it's gonna impact and corrode this section, but the impact is much less than previous configurations, and it gave us sometimes more than 6 months, and we were able to purchase the new to install the new valve in new type. But I said that the best type for this application is angle type. That's right, based on experience and literature, it is angle type. But we also made another mistake. This is the angle type because angle type is the one of configuration of angle type because angle type can provide and offer less direction change. Here we made another mistake. Here is the angle type. In our first design, we didn't consider that when the outlet velocity of angle type is really high and it impacts this section, impacts this elbow. So after installing these ones, we had corrosion in these sections, in this elbow. We talked to the vendor, to the piping specialist, to the QC engineers, and they said that the best option is to provide this elbow with better material. We replace it with better materials, and so far so good. The problem was solved. And here is our experience and mistakes. I hope that this episode, these mistakes, this experience would work to the advantage of your career and you wouldn't make such similar mistakes in your career. Have a good day.